Okay, we can get started. Since it's a couple minutes after 6 and maybe more people will come in and we're recording the session. So hi everyone, thank you so much for coming to our COVID-19 vaccine workshop in collaboration with the Texas Tech University Health Sciences Center, specifically the EP Heat team. We are really excited to share this presentation tonight. We're going to share a lot of helpful information and resources related to the COVID-19 vaccines. If you have any questions along the way, please feel free to leave them in the chat, or you can wait until the Q&A session at the end. So I'm going to take this opportunity to let the EP Heat team introduce themselves. Thank you so much for being here tonight. Dr. Chacon, if you want to start us off, that would be great.
Thank you so much, Winnie. It's a pleasure to partner with PPMA and to discuss a very important topic about the vaccine development, specifically regarding COVID-19. I want to thank Penn Pre-Med Association, all of our presenters today, and then my Texas Tech team in El Paso. And with that, I will pass it over to Sarah.
Hi, my name is Sarah Johnson. I'm a first-year medical student here at Paul L. Foster School of Medicine. I went to Indiana University for undergrad. I graduated in May 2020. Carlos and Kay, if you want to introduce yourselves real quick before I begin.
Sure, thanks, Sarah. My name is Kay. Hey guys, I'm a third-year medical student here at Paul Foster School of Medicine. I am a graduate of the University of Pennsylvania, class of 2017, the college. I majored in economics, and I'm now here, back in my hometown of El Paso. So I'm really excited to partner with you guys. I was also part of PPMA back in the day, and yeah, I'm really excited to give you guys this presentation.
And hi guys, my name is Carlos Bouchot, and I am a third-year medical student here at Paul Foster too. I graduated from the University of Texas at Austin, class of 2018, with a major in biology, and now I'm here in El Paso.
All right, thanks guys. So I'm going to start off by just basically talking about COVID-19. I'm sure we're all familiar with it, but in more scientific terms, COVID-19 is the disease caused by SARS-CoV-2, a newly discovered virus in the family Coronaviridie. SARS-CoV-2 is the virus, and COVID-19 is the disease that it causes. SARS-CoV-2 is a positive sense single-stranded RNA virus, which is spherical in shape and enveloped with club-shaped spikes on its surface. It's mostly spread through close contact or respiratory droplets, but it can also be spread through direct human-to-human contact or by contact with contaminated surface or objects and then touching your mucous membranes, such as your nose or your eyes or your mouth. I had a biology teacher once who explained viruses as some kind of genetic material, either RNA or DNA, and then a protein coat. So viruses are really simple. And if we can get to the next slide, we're going to talk about COVID-19 entry. Okay, so COVID-19 is contracted through the nose, mouth, or eyes, and then it enters the cells of the nose, mouth, or eyes using the spike protein. So that's the picture on the last slide that we saw with the clubs. So that binds to an enzymatic domain of the human angiotensin converting enzyme 2, or ACE2 receptor, which is found in most organs in our bodies. The binding of the spike protein to the ACE2 receptor allows for endocytosis of both the virus and the enzyme receptor into endosomes, or directly through membrane fusion. So since COVID-19 is a positive sense single-stranded RNA virus, once it is released from the endosomes directly through the cell into the cytosol, its information will be copied into more viral material directly via host cell machinery. This is how the virus builds more copies of itself in our cells, and we'll flip to the next slide for specifics. So once SARS-CoV-2 enters the cell through binding of its spike proteins to ACE2 receptor, it allows the virus to enter the cell. It then releases its RNA into lung cells, which are called pneumocytes. The positive sense just means that it can start replicating itself right away. The virus uses host cell ribosomes to translate its own mRNA into proteins. Some of the most important structural proteins it makes are the nucleocapsid, spike, membrane, and envelope proteins. It also makes specific enzymes called proteinases. The ribosomes can synthesize all of the structural proteins in one go, and then the proteinases can cleave the proteins into different components, like tiny little molecular scissors. After it makes these, it can use RNA-dependent RNA polymerase. So it uses the RNA to make more RNA, to make more copies of itself. And as we just said in the beginning, viruses, especially SARS-CoV-2, it's just genetic material in a protein coat. So the virus steals the cell's machinery to make more copies of itself and its proteins to make more viruses. And in the process, the lung cell gets damaged. So if we can go to the next slide to talk about the inflammatory phase. So in a significant number of patients, the virus produces a severe lung illness called acute respiratory distress syndrome that can lead to respiratory failure requiring hospital-assisted mechanical airway ventilation. That's a mouthful. So in many patients during this stage, the body's defense mechanisms do more harm than good by producing inflammatory cytokines that can first damage the lung tissue, but then put the rest of the body on alert, causing blood clots, multi-organ failure, and even death. This inflammatory response by our bodies is called the cytokine storm. You might have heard of that in the news, and that's essentially what the cytokine storm is. It's just your body's immune system going into overdrive. So some medications that have been studied are remdesivir, dexamethasone, and other medications. So remdesivir is an antiviral medication, and it's shown to shorten the time until recovery in some hospitalized patients, but it hasn't been shown to reduce the amount of deaths. According to a study by the UK National Institutes of Health, the number of COVID-19 patients requiring mechanical ventilation was significantly lower when patients were given dexamethasone, which is a glucocorticoid or a steroid, compared to those in control groups. So dexamethasone acts on the body by reducing the immune system's ability to produce those inflammatory molecules or cytokines, which is the thing that does the most amount of damage. And by tamping down the cytokine storm, the goal is to reduce the amount of damage done by the immune system. So if we can jump to the next slide. So treatments are trying to help, but the best way to end this thing is through vaccines. So vaccines are the only type of medicine which prevents the onset of disease, whereas other medicines are trying to treat or cure diseases. Vaccines contain the same germs that cause disease, but they have been either killed or weakened to the point where they don't make you sick. Some vaccines contain only a part of the disease germ. So in the example of COVID-19 or SARS-CoV-2, the vaccine mechanism is RNA. So mRNA sequence, which codes for specific pathogenic protein, in this case, the spike protein, is introduced and the protein is produced by the host cells, generating an immune response. It stimulates your immune system to produce antibodies exactly like it would if you're exposed to the disease without the risk of developing all of the really harmful and truly scary side effects of the disease. And now I will pass it off to Kay to talk about more vaccine specifics.
Thanks, Sarah. So yeah, as Sarah was mentioning, what did she say? Can anyone remind me in the chat? What is the target that we're targeting for COVID-19 for vaccinations? I just want to kind of get an idea of you guys kind of got like what we're targeting in order to prevent the disease of SARS-CoV-2, which is COVID-19. By the way, SARS-CoV-2 stands for severe acute respiratory syndrome caused by coronavirus. So I just wanted to like clarify that abbreviation. But anyone? Does anyone remember what it was called? No? No one in the chat? There we go, spike protein, very good, very good. So the spike protein is what a lot of these companies that we see here on this board are targeting with regards to a COVID vaccination. So I have pretty much put in square everything that's been funded by the Operation Warp Speed, which was the government entity that was pretty much put in place in order to fund a lot of this research and development for a lot of these COVID-19 vaccines. So Pfizer and BioNTech was one of them, Moderna, Oxford and AstraZeneca, Johnson and Johnson, and Novavax are some of the examples. Now, here are all the vaccines that are pretty much already on phase 3, which is pretty much about the end of the cycle of approval for use worldwide. So the ones that have been approved so far, we'll talk about it a little bit. It's been Pfizer, Moderna, and the Johnson and Johnson vaccine here in the US that have received emergency use authorization here in the United States. So Moderna and Pfizer, what do they have in common? They're mRNA vaccines. And as Sarah was mentioning, mRNA technology pretty much introduces a copy of the template into our cells and then uses our cells machinery in order to create that same spike protein in our cells so that our own immune system can create a response against it. Now, Johnson & Johnson and Oxford AstraZeneca are using adenovector vaccines, which pretty much use the adenovirus, which causes the common cold. And we introduce the DNA portion of the spike protein and pretty much introduce it into our cells through that adenovirus so that our body can create that spike protein again, but from a DNA form. And then the Novavax pretty much just introduces that specific spike protein into our cells, and we can do that. So if we can click next so we can see the picture. So here's the three types of corona vaccines in development. As we said, protein-based, that's like the Novavax. We're pretty much purifying and injecting that that spike protein into our body so that our immune system can produce an antibody response. And number 2 is adding a viral vector, and as you may see, that's the adenovirus. So that our own body produces a spike protein, creating the immune system. And then we're pretty much skipping the next step to do the mRNA and then producing the spike protein. All in all, leading to the same end result, which is the immune system producing the antibodies. All right, let's go to the next slide. So here's a little bit about how the Pfizer and BioNTech vaccine works. So the central dogma of biology, right? We go from DNA to mRNA to proteins, right? So DNA gets transcribed to mRNA, mRNA gets translated to proteins. So what the CDC did and Pfizer as well, like all these pharmaceutical companies received pretty much the code for what the mRNA sequence was for specifically for the spike protein. And previous to this pandemic, the mRNA vaccine technology had been studied for 10 years, but it's a really expensive technology because, as we may know, mRNA is very unstable. So let me see, when developing mRNA, why did these companies choose to use RNA that would be translated as opposed to DNA that would be transcribed and translated? So excellent question, Sydney. So as I was about to mention, the mRNA vaccines, right, we're able to produce it relatively quickly. We don't need to use live cells, different cell lines in order to produce the mRNA. So that makes production a lot easier. However, they were developing these in the past, but they were pretty much inhibited by a lot of the costs associated with it. So one of the main reasons we're able to use this mRNA technology to place it into our cells now is through this mRNA lipid nanoparticle that we can surround it around, which allows it to be a little bit more stable and allow to get to inside our cells in order for it to be translated into the proteins. Okay, so that's how it kind of works. We're going to go to the mRNA, the Moderna drawing next. So yeah, so this is an even better example. So we can see how that lipid nanoparticle encased mRNA enters our cells, right, through what, endocytosis, right? So that ribosome will pretty much translate that mRNA and create that viral spike protein, as you guys may see. And we can go to one of two ways. You guys may hear in the news, right? Like antibody response is very important, but T cell response is just as important as well, right? So why do we need both? Why? Because antibodies can neutralize the virus, right? Whenever we're faced upon it. But T cell response can pretty much kill off any cells that are severely infected by the virus in order for us to fight the infection in a better way. And we have a few more lines of defense prior to the coronavirus really causing the disease within our bodies. So I don't know if you guys have taken biology yet, but MHC1. So that's pretty much an antigen within an antigen presenting cell is going to call towards the CD8 cells, and they're going to learn pretty much that structure of the spike protein so that in the future occurrences, you pretty much have a cytotoxic T cell response whenever they see a cell that's infected with the coronavirus. So they'll kill that off in order for it not to replicate, right? So now in other antigen presenting cells as well, we have MHC2, right, which will bind to CD4 helper T cells, which will communicate with the B cells and to create plasma cells that will create the antibody response that we see here. Okay, so let's click next real quick. And as you guys may see right here, this is a perfect example. So we have an antigen entering and you have pattern recognition receptors that'll endocytose, right? Breaking down that protein and being able to present it within the MHC2 and MHC1. And as you guys may see, the result of the MHC2 process ends with antibodies produced by B cells. And then the MHC1 results is creating cytotoxic T cells that are ready to respond whenever you're infected with a COVID vaccine. All right, let's go on. Any questions so far? Make sure, feel free to add it into the chat. So now let's go over the Janssen vaccine. Janssen is a subsidiary of the Johnson & Johnson. So you guys may, if you guys get vaccinated with the Johnson & Johnson vaccine, you may see Janssen, but it's because they're the ones that really created this vaccine, but they're under the umbrella of Johnson & Johnson. So what did they use, right? So they pretty much grabbed that genetic code again, but this time of DNA of the spike protein, and pretty much encapsulated it within the adenovirus, which is just a common cold virus, as I said. And what it does, let's click on the next picture. Perfect. This is a perfect picture because what it does is this adenovirus is infecting your cells, right? But it's a non-replicating adenovirus, which means that you should not be getting a severe cold infection from it because it's not going to replicate and create more adenovirus within your body, right? So once that virus gets endocytosed, right, they'll take out the coating and stuff like that, but it's still, we have the proteins in the outside, but we still have the capsid that's surrounding that virus. And that capsid is going to slowly travel down into your nucleus in order to insert that spike protein viral DNA. And what do? We have the DNA polymerases that will pretty much read that spike protein DNA and transcribe some mRNA. And then we're back to the square where we were in the Moderna and Pfizer, where we have the mRNA that will go into our cytoplasm, use the ribosomes that we have, and create that spike protein and do that MHC1 and MHC2 process all over in order to have both antibody and what's called a T cell response as well. All right, let's go next. So Carlos is going to talk to us about how all of these vaccines, so that was all the theory of how it works, right? So now let's find out how well these vaccines actually work.
Yes, so yeah, we wanted to give you a little bit of information on the current state of the vaccination efforts. So right here we see the 3 currently approved vaccines under emergency use authorization by the FDA, which of course are the Pfizer, the Moderna, and the J&J. We can see the similarities there between the Pfizer and the Moderna, both of which use the new mRNA technology that Kay was talking about. And we can compare that to the J&J vaccine, which uses a more traditional type of vaccination method. All of them have pretty high efficacy rates, ranging from 66%, as we can see, from the J&J up to 95% for the Pfizer and the Moderna. And they're even better at preventing severe disease and hospitalization, as we can see. Also, we decided to add a column on whether trials are being conducted on right now to see if they're safe and effective for pregnant women and children. As we can see, the Pfizer and Moderna are already both in trials with J&J in the planning stages. So we can look forward to getting some vaccines for those populations in the near future. Finally, we have a column on the right side on the 3 vaccines efficacy against the new and emerging variants around the world. As we can see also there, most of them are effective at least against at least one variant, with the J&J is showing efficacy against both major variants at the moment, the UK and the South African. And if we click next, we're getting on to some barriers to getting the vaccine. Okay, so what's stopping people from getting their vaccines? This chart is from a poll conducted in Israel on vaccine hesitancy, and it's very similar to the numbers we're seeing in the US right now. People were asked why they were hesitant to get the vaccine, and their responses were recorded. And here the investigators divided the responses into 3 different broad categories, which are safety, efficacy, and disease is mild. Basically, is the vaccine safe? Is the vaccine effective? And people sometimes are just not getting the vaccine because they say that the COVID-19 disease is pretty much mild for them. So they're just rather not get it. And as you can see, each category has different yet similar sub-responses. So when trying to address vaccine hesitancy, either with our friends, with our family, with our patients, we should try to focus on these items to try to combat vaccine misinformation, and using data such as this in order to attack the problem of it at its source. Okay, so now that we know how the vaccines were produced and how they're effective, and we have people getting the vaccine and people wanting to get the vaccine, hopefully with efforts to combat vaccine misinformation. So now how do we get vaccines into arms? And if we click on the next slide, here we see the logistics of the US vaccination rollout. So back in December, we saw the first vaccines get emergency use authorization by the FDA to start distribution. And within days, we had the first vaccines getting injected into the arms of doctors and nurses all over the country. And here we see the different stages that we have according to the ACIP, which is the Advisory Committee on Immunization Practices. Right now, most states are in phase 1C, as we can see on the right, which include people who are 65 and older, people with people 60 and older with underlying medical conditions, and healthcare workers, some frontline essential workers. And some states are, including like Alaska and other states, are even moving on to the general population right now. So we can look forward to many more vaccines coming in the near future. And now I'm handing it off to the Penn team.
Thank you so much, Sarah, Kay, and Carlos, for that super helpful and informative presentation. Now we want to move on to the interactive portion of this presentation. So with the emergence of the COVID-19 vaccines, there are often many assumptions or false and misleading information in circulation. So it's really important for us to be able to differentiate between myths versus facts and make sure that we are always referring to reliable and credible sources when we are looking up information. So we prepared this fun game of true and false, where we will address some of the more common misconceptions that circulate either online or through word of mouth. So there will be polls that pop up after each statement, and you can just anonymously answer to the best of your ability. So the first question is true or false: the current vaccines will be completely useless against new COVID-19 variants. So I'm going to launch this poll, and I'll give you guys a couple seconds to vote. So here are the results, and 100% of you guys said false, and that is correct. So different variants of a virus emerge as a result of mutations that occur within the virus. So it's perfectly natural for RNA viruses to eventually change over time, especially if they're exposed to different geographical environments. So specifically, there are a lot of different COVID-19 variants today. One example is the B117 variant, which was first seen in September 2020, and it has become a very common variant in the UK. So it's spreading very quickly, not only in UK cities, but also in other regions, including the US, and it's becoming one of the more dominant variants that we see. So another interesting variant that we see is the B1351 variant that first emerged in South Africa. So this variant is very similar to the B1171 one in the UK. But as of right now, there's no evidence saying that this particular variant causes any changes in disease severity. But one important difference is that there's a mutation within this South African variant that makes it more contagious. So the main thing that people are worried about right now is that it'll cause it to spread more quickly. So evidence from research studies have shown that even though there is some reduction in vaccine efficacy when it encounters new variants, ultimately the vaccines still offer a very significant level of protection. So overall, this statement is definitely false because taking the vaccine is better than having no protection at all. And the efficacy of the vaccine ultimately depends on the dominant variants that are in your geographical region. So researchers are also continuing to conduct studies to look into this more and track the mutations. So the second statement is true or false, getting the vaccine means that the COVID-19 virus will be entering my body. So here's the poll. So it looks like we got more of a mixed response here. So most of you guys said false, but there were a couple of trues. So the answer is false. So the Pfizer and Moderna vaccines are both mRNA vaccines. So this means that they don't contain any live COVID-19 virus, which is a common misconception. So the mRNA vaccine basically lets your body create a spike protein, which I believe Sarah and Kay touched upon a little bit earlier. And this spike protein then allows for your immune system to produce antibodies. And that in turn allows your body to recognize the vaccine, the virus, if it ever encounters it in the future, and know how to fight it. So the new Johnson & Johnson vaccine is a little different because it's not a mRNA vaccine, but instead a viral vector vaccine. So regardless, it still does not contain any live virus, but instead it contains an inactivated adenovirus, which is basically just a typical virus that causes the common cold. So the adenovirus releases viral DNA, which allows for the production of spike proteins, which follows the same pathway as the spike proteins from the mRNA vaccine. So just to reiterate, it's really important to recognize that all of these vaccines don't contain any live virus and there's no chance of infection.
Okay, thanks, Winnie. So the next true or false statement is getting only the first vaccine dose, Moderna or Pfizer, is sufficient protection against COVID-19. So I'll let Winnie launch the poll. And it looks like there is, again, some trues, but mostly falses. And the correct answer is false for the most part, and I'll get into that. So a little bit of background about the vaccines. There are two doses for the Pfizer and Moderna vaccines. The first one is the priming dose, and the second one is the booster shot. So for Pfizer, there are research studies that show that the first Pfizer dose does provide some protection 12 days after administration of the first dose, but the efficacy is pretty weak, which is around like 52% successful, which is going to be much lower than the 95% efficacy rate after the second dose. There's also not a lot of data on the participants that did receive only one shot. So this number for the efficacy rate of 52% that I said is not as reliable as the efficacy rate of the second dose, which I said was 95%, as those participants who didn't receive 2 vaccine doses were generally only followed for a short period of time. So we couldn't really conclude anything definitive about the duration of protection of the single dose of vaccine reported by the companies. And a final note about that is that it's also very important to make sure that the same vaccine is followed up for the second dose, because the effects of mixing the 2 doses of the vaccines, like getting Pfizer then Moderna, is not established yet. And again, to talk about why there is 2 doses, this first dose, as I said, is the priming dose. And so this helps your body to recognize the virus and prepares your immune system. And then the second dose, which is the booster shot, strengthens your immune response. So it's important to note that many vaccines that have been utilized for other diseases and other viruses require 2 doses. Like vaccines against hepatitis B, diphtheria, and tetanus are prime examples. So the dose schedule and number of doses are also applied in clinical settings. So it's very important to take the vaccines as they were intended to be distributed. And so to talk about the Johnson & Johnson vaccine that we had talked about. So this is the only FDA approved 1-dose vaccine as of right now. So this vaccine has been proven to be only 85% effective in trials against severe cases of the disease and 66% effective globally against moderate to severe cases of the disease. So because there's only 1 dose that is necessary, recipients of the vaccine are able to be better protected faster than those that require 2 doses, but its efficacy rate is lower, as we had previously discussed. Okay, so second statement, true or false? Booster shots after the second dose may be necessary to maintain protection against the virus. So Winnie will show the poll. And it looks like the majority of people said true. And the correct answer is true indeed. So as I talked about, the second dose that we do get after the Pfizer Moderna vaccine is the booster shot. But so Pfizer and Moderna are also in the midst of studying a third dose. So the goal is to increase efficacy even more so by increasing the antibody response and also to protect against other variants. It's very possible that additional doses will be necessary over the next few years, but again, this is all in the process of being researched still. And this is very reasonable, as the first dose, as I said, is the start of building the protection against the virus, and the second dose reinforces that protection. And so as like a general comparison, we can think about how people take the flu shot every flu season. And so this is necessary because new variants of the flu virus are constantly emerging, and the flu shots need to be adjusted accordingly. So yes, it's true that booster shots may be necessary later on.
So our next question is true or false, pregnant women cannot take the vaccine because it'll affect the development of the placenta. So yeah, it looks like everyone said false, and that is true. The current main COVID-19 vaccines are safe for pregnant women. Now, according to studies, there are many pregnant women who are specifically reluctant to take the COVID vaccines because of concerns about the side effects on fetal or placental development, the vaccine being rushed for maybe political reasons, or the lack of vaccine safety data for pregnant women. Now, to address some of those concerns, first, mRNA vaccines in particular do not contain any virus particles, only mRNA particles, as was previously mentioned. And these particles are eliminated or degraded by our bodies within hours or days. So it's pretty unlikely that these mRNA particles would ever cross the placenta. It's also important to note that mRNA vaccines cannot alter human fetal DNA because the mRNA doesn't actually enter cells nuclei, which is where the DNA is stored. Now, just in general, the benefit of taking the vaccine while pregnant is that the immune response or the immunity developed by a pregnant individual can cross the placenta, thus keeping the fetus safe. And finally, just overall, in humans, we know that other kinds of vaccines are generally safe for use during pregnancy. So it makes sense that this would be false. Now, for the next question, it's true or false. Since I already had COVID-19 before, there is no point in getting the vaccine. Yeah, so it looks like most of us said false, some true as well. In general, the answer is false. If you have already been sick with COVID-19, you do have some natural immunity, but it's still possible that your body will not produce a sufficient immune response. Studies have shown that approximately 90% of participants who've previously had COVID-19 have produced a sufficient immune response, even 6 to 8 months after their diagnosis. Therefore, it's pretty clear that natural immunity does offer some protection. However, around 10% of patients in that study were still prone to getting sick again. And current research studies are still in the midst of determining how long it takes before this natural immunity wears off. So long story short, don't take the chance, just get vaccinated if you are eligible. Now, it's important to also note that given a limited supply of vaccine doses, other studies have shown that for people who have had COVID-19 before, even one dose of the 2-dose regimen from Pfizer and Moderna still yields a higher antibody response than 2 doses for people who've never had COVID-19 before. And finally, just an FYI, the Mayo Clinic recommends waiting at least 90 days after a COVID-19 diagnosis before getting the vaccine. So that's helpful to keep in mind if that applies to you.
All right, so the next question is, should you not take the vaccine if you have any allergies? All right, so most of you guys said false, which is correct. So the number of allergic reactions to the vaccine is very low. Based on CDC guidelines, people with allergies to penicillin, latex, eggs, dust mites are still able to take the vaccine. And the exception is that if you had a past allergic reaction to any of the ingredients in the vaccine, such as PEG, so there's a list of ingredients posted online. You should check if this applies to you. And if you have any history of allergies, the CDC recommends that you stay in the hospital or at the clinic for at least 30 minutes after receiving the vaccine to monitor if there are any side effects. And also here is a good flow chart to check to see if you can get the second dose. So ultimately, it's best to check with your doctor if you have any hesitations about any allergic reactions or anything. All right, so the next question is, the vaccines aren't safe because they were developed quickly. All right, so most of you said false, and this is correct. So researchers were not starting from scratch when they learned about SARS-CoV-2. There are hundreds of coronaviruses, including 4 that caused the common cold, as well as the coronavirus that sparked the SARS epidemic in 2002, and also the Middle East Respiratory Syndrome in 2012. So additionally, mRNA technology is something that scientists, including scientists at Penn, have been working on for a very long time. And all the guidelines for clinical trials were followed. And one factor that makes it faster to distribute the vaccine is an increase in funding.
So with the increase in funding, companies were able to produce and stockpile vaccine doses before the company even knows if the vaccine was going to work. And then once it is confirmed that the vaccine works and is safe, then it can be distributed. So this is how we were able to get access to the vaccine very quickly after it was confirmed that it was safe and effective. So yeah, long story short, much research have been done on the vaccine, and CDC states that it is very safe and effective.
Okay, so true or false, it is safe for people with suppressed immune systems to get vaccinated. Okay, great. So the majority of you said true. So let me explain. So our immune system is composed of a group of cells that defend our body from infection, right? And when someone is immunocompromised, their immune system obviously operates at a lower efficiency. So their body is basically unable to properly fight off an infection or a disease. So several factors can contribute to that, to an individual being immunocompromised, including certain diseases or autoimmune disorders such as HIV or even type 1 diabetes, or chemotherapy and immunosuppressant medications, or even your lifestyle and age. And these individuals are more prone to being infected by COVID-19, and they are at an increased risk for severe infection by the virus. Also, the data for safety and efficacy of the COVID-19 vaccination in these individuals is limited, but the data that has been obtained so far has shown nothing to be concerned about, especially since the vaccine does not contain a live virus. There's only one strand of RNA for making a part of the virus, not the entire virus, and it's not infectious. Similarly, the other promising vaccines do not contain infectious agents either. Also, it's important to think about the concept of herd immunity. So when the majority of a population is protected from a disease, this means that the virus has fewer opportunities for people to infect other people. So if we all get the vaccine, then we become part of that protected herd that also protects others, including those that, yes, are immunocompromised, but also young and healthy people alike. Next, true or false? Once I get vaccinated, I do not have to wear masks or practice social distancing. Okay, great. So the majority of you said false. That's correct. So you do still need to wear a mask and practice social distancing, because how do you know who is vaccinated, right? And it's important to keep in mind that no vaccine is 100% effective either way. While they are 95% effective, which is incredibly high, that still means that 5% aren't protected potentially. Also, while the vaccine does reduce your risk, it does not eliminate the risk of being exposed to having the disease and asymptomatically transmitting the virus to others. So we know getting a COVID-19 vaccine reduces the chance that you will get sick, but even if you get the vaccine, you might still be able to carry the virus and spread it to others. And these are called silent spreaders or hidden carriers because they do not develop any symptoms. As I mentioned, they can asymptomatically transmit the virus. And this in some ways can actually be very dangerous because this person might not be aware that they have the virus and they think it's perfectly safe to be around other people. Also, another point is that we do not only have to worry about these silent spreaders, but also if someone has had the virus and gets the vaccine, because there is still that possibility of reinfection, as was mentioned before. Also, interestingly, Penn Medicine actually just reinforced this last week that vaccinated people can spread COVID-19, since yes, the vaccine will protect the vaccinated person from the severe effects of the virus, but some level of transmission to others can be possible still. Similarly, they mentioned that some studies suggest that new variants of the virus can partly escape the immunity that is provided by the vaccines. So it is definitely still recommended to continue wearing a mask even after you've been vaccinated.
So that concludes the interactive portion of our presentation. Thank you so much for everyone for participating. So here we want to share some Philadelphia specific resources. So the first link is a sign up link for the COVID-19 vaccine interest form. And it's helpful to be signed up to this because they contact you when there are new updates, for example, regarding your eligibility. And then the second and third link are just basically answers to frequently asked questions about distribution plan information and phased approach updates, etc. So it's really helpful if you have any follow-up questions, you can refer to those links, or you can reach out to any of the 3 medical students that attended the presentation today or the PPMA board. And this is the contact information if you want to reach out for any follow-up questions. So at this point, if anyone has any questions, feel free to unmute yourself or you can type it in the chat. So we did receive some questions submitted in advance. We have something in the chat. Okay, so first we can answer this one. So what constitutes herd immunity and how many vaccines will need to be distributed for that?
I can take a crack at this one. So herd immunity, right, means having enough people inoculated, right, in a population in order to pretty much completely or pretty much almost close to completely inoculating the virus completely in a sense in which it becomes no longer a pandemic, right? So there are various numbers thrown around, whether it's 70%, 80%, 90%. But from what we know is our goal is to really vaccinate as many people as possible. And if possible, 100% of the population, right? So, but I think it all comes back to behavior and just we need to work together in which, like, if you know the people around you are vaccinated, then it's probably, you're probably safe in that environment, right? So the closer we get to 70%, the more people around you will be vaccinated at that point. So I know Dr. Fauci has thrown around percentages like 70 to 75%. So that's what they're aiming for. And I think with the current projections of vaccine rollout, we should hopefully get there anywhere by the end of the summer. So, but that's an optimistic view. What do you have anything to add on it, Sarah?
Well, I was just going to say it's also important to remember that inoculation can both be through vaccines and through our natural immune system if we get COVID-19. Obviously, vaccination is the more ideal route. But I read a study, and between people who have gotten infected and people who have been vaccinated, the current estimates are somewhere between 35 and 45% of the US population has some form of immunity, which is a really good start, seeing as we're marking a year of living the pandemic. So hopefully by the end of the summer, that'll be a much higher number, and basically anybody who wants the vaccine can get it, and we can encourage more people to want to get the vaccine.
I 100% agree, Sarah, and I think you bring up a good point because we have seen a dramatic decrease in positive cases of COVID. Pretty much once this vaccination has pretty much helped us reach close to 40 to 50% of the entire population being either having natural immunity to wild type virus or to the vaccine. So.
And one thing that I can add is remember that herd immunity makes it hard for the virus to spread from person to person. There's a lot of little people right now that aren't eligible to receive the vaccine whose lives have been probably impacted the most. And I'm talking about the kids. So kids love to be around each other, they love to socialize, and now they're all mostly at home virtually. So do it not just for ourselves, but also those who are not able to get the vaccine yet. Younger brothers and sisters, newborn babies. I have 2 kids myself, so I do it not only for myself, but also for them.
Thank you so much for those answers. That was great. So another question we had was, multiple vaccines are now emerging in the market. Is there any particular one that you would recommend is better to have over the others? So
Everything I've heard from the experts is take whatever vaccine you can get. They're all great. They're all safe. They're all basically the same effectivity at preventing severe disease. So take whatever one you can get.
100% agree with Sarah. The key here is we want to decrease hospitalizations. We want to prevent death. So because of that, all three vaccines do an excellent job at doing that. So because of it, if you're able to decrowd the hospitals, I think we have a better chance at helping people who actually would normally contract severe disease. So, yeah.
So another question that was previously submitted, this kind of follows what Dr. Chacon mentioned earlier. So the student wanted to know whether or not pediatric trials have been conducted and about the ethics behind vaccine trials.
So I can take this one because I kind of sort of touched on that on my part. Right now, we are seeing trials for kids aged 12 to 18 for the Pfizer and the Moderna. Not yet on the J&J, but they're all moving in that direction right now. And as to the ethics of it, I mean, as long as we can prevent death and prevent severe disease, I mean, I think it's for the benefit of all.
Yeah, and I can also add in with regards to the ethics, right? These are voluntary participants who are who are added to the trial. And one of the reassuring things is that like COVID has not been known to cause even this like close to the amount of severe disease in children. Yes, we've heard of MIS-C, multiple inflammatory syndrome in children. However, it's a very, very, very rare disease. So because of that, like I think in order for us to prevent that kind of disease, which is already rare in itself, and if we can create something that's safe along the process, I think the ethics check out, especially because it's a voluntary trial.
And y'all can feel free to correct me if I say something wrong, but in terms of vaccinating pregnant people and testing people who get pregnant after having contracted or after having gotten the vaccination, you can select in your post vaccine checkups with the CDC whether or not you've gotten pregnant or have had a positive pregnancy test. And so my guess is what they're going to do is do a retrospective study on people who have become pregnant or people who were pregnant while receiving the vaccine. And one of the benefits that a lot of people have mentioned when receiving the vaccine while pregnant is that your body produces IgG antibodies, and those can be passed on to the fetus so that they're born with some level of natural immunity that will stay with them while they're learning to produce their own antibodies.
I actually had a quick question. It relates to the Astrazeneca vaccine. So recently in the news, I've been hearing that over a dozen European countries have been banning the use of the Astrazeneca vaccine because there have been quite a few reports of people receiving the vaccine and then developing blood clots. So I was wondering if you can talk a little bit on behalf of that.
Yeah, I can talk on behalf of that. So there have been some reports that have come out about blood clots developing through the AstraZeneca, but we have to understand that COVID-19 wild type, like that, the actual natural virus, the disease does increase your risk of having blood clots, right? So it's a process in which like, yes, like you might develop the clots if you get the vaccine, and then but there's also an incidental thing where like as like through the natural virus, you're already at a higher predisposition of getting blood clots through COVID-19 as it is. But I had just recently listened to a EU announcement that they had just said that the retrospective, they looked back at all those cases that had the blood clots. And even with that, they still considered it to be safe and effective in the EU. Obviously, it still has not passed FDA trials, so it's not going to be used in the United States. Not for at least the next month or so, right? Until they finally submit their approval for emergency use authorization. But yeah, I think it's an excellent concern to have. But it's always good to understand like how COVID-19 actually works, because it's like if it increases your risk, but like the natural infection will increase it even more, right? But I totally understand that concern. But great question.
It's also important to remember that Europe has, in general, overall, more vaccine hesitancy than the United States and other parts of the world. So it's not kind of out of left field for Europe to suspend that policy, just generally speaking, in terms of the culture. So they'll probably do more rigorous testing, but they're generally speaking more vaccine hesitant of all vaccines, not just the new COVID-19 vaccines.
Thank you.
So unless anyone has any other questions, I think that was it for all the pre-submitted questions. And for the PPMA members, please sign up in the link in the chat. That's just our attendance form, so we can note your attendance. Does anyone else have anything they want to ask while we're still here?
I just want to take the opportunity to thank all the presenters today and thank the PPMA, especially their leadership team, for giving us the opportunity to put on this joint panel. I think it was very, very informative. I'm very, very excited about future collaborations with our teams. And again, I thank Winnie for continuing to be our close collaborator with our workshops. And thank you again, all the presenters did a really, really remarkable job. So thank you.
Excellent job, guys. Yeah, excellent job to all you guys. PPMA, you guys are doing a great job. It looks like we left it to good hands, you know, in the future. But yeah, I'm really excited. Hope you guys all apply to medical school soon. And if you guys have any questions, you can always reach out to us in the process. And yeah, good luck. Good luck to all of you.
Yeah, if you guys have questions, whether it's about COVID, applying to medical school, PA school, dental school, whatever it is, reach out to us. We can try to help. So thanks for coming.
Thank you guys so much. I'll send the recording to the EP Heat team, and then we'll also share it with the rest of the PPMA members who couldn't make it tonight. But thank you again. This was really great.
Thank you.